Alright y'all, how's it going? I wanted to put together a little video just because we've been working on writing equations in point slope form and there seems to be sort of a general confusion. I'm hopeful that these few examples will help you figure out sort of the process. So as we're doing this work, I've really broken it down into 4 primary steps. As you're doing this work, you may use some, all, or none of these steps depending on where you are in this sequence. So using this framework, the first thing we want to do is we want to determine the slope. So if we look at this question prompt, it says write an equation of a line in slope-intercept form. Now to start off, we know that slope-intercept form is the equation y equals mx plus b. In this situation, the y and the x stay as they are. M is going to be your slope, which is your rise over run, and then b is going to be your y-intercept. This is the point where the graph crosses the y-axis. So in this situation, they give us a slope and they give us a point. They don't give us the slope-intercept or the slope and the intercept. So this is where we're going to have to leverage the point-slope equation. So the point-slope equation is going to look something like this. It's actually very similar to the slope formula, or the formula that we use to solve for the slope. It's just a small variation of that. So in this example, or in this equation, the y and the x stay the same. The y1 and the x1 is where we manipulate things, as well as the m. So in this case, we want to determine the slope. So based off of the question prompts, they tell us the slope is equal to 5. The next thing we want to do is we want to figure out what our x1 and our y1 are. So x1 is actually the x-coordinate of the given point. So x1 is going to be 1, and then y1 is going to be the y-coordinate of the given point. So that's negative 4. Okay, so now that we've identified the 3 major players, all we have to do is take our formula and sub in those values. Now the thing to keep in mind is if we have a negative coordinate, we essentially make it addition. So y minus a negative 4 is the equivalent of saying y plus 4. That's equal to our slope, which is 5, and it's going to be x minus x1. In this case, x1 is just 1. So now that we've written the equation here in point-slope form, what we can do is distribute this 5 to both of these terms. So if we bring this down here, y plus 4 is equal to 5 times x is 5x minus 5 times 1 is just 5. Now the last thing we want to do to isolate our y variable to put it into slope-intercept form is to subtract 4. Then you'll notice as you watch more of my videos, I draw a line under each operation that indicates I want to refresh my equation. Negative 5 minus 4 is negative 9. Now that we have the equation in slope-intercept form, I can ask you what the slope is, which we already know, which is 5, and then I could ask you what the y-intercept is. In this case, since we have it in slope-intercept form, the y-intercept is our constant value, which is going to be 9. So again, this may seem like it took a fair amount of time, but as you do more and more practice, it's going to get easier and easier. One thing that I'm finding in class is people don't want to write things down. So they're trying to hold all of these steps in their head, and they're missing key steps, especially when it comes to integrating fractions into this work. So please, if there's, for whatever reason, if you are not writing these things down, make sure that you are and really defining the process, because that's going to go a long way in helping you understand this material. So here we want to write the equation of a line in slope-intercept form. They give us some information. They tell us the slope is 4 and the point is 0, negative 4. Now knowing what I know that all y-intercepts have an x-coordinate of 0, so I could say my slope is 4 and my y-intercept is going to be negative 4 because that's the y-coordinate when x is 0. However, if you're not there yet, we can still leverage the point-slope form to do this work. And remember, from our last slide, the point-slope form is going to be y minus y1 is equal to m times x minus x1. Okay, so we need to determine the slope. They give us the slope. They tell us that m is equal to 4. We need to figure out what our x1 is. In this case, x1 is 0. y1 is going to be negative 4. And then what we can do is take our equation, y minus a negative 4 ends up being y plus 4 is equal to 4 times x plus or minus 0. Either way, it ends up being 4 times x. If we distribute, actually let's clean this up a little bit. So we got y plus 4 is equal to 4 times x, which is 4x. We could say plus 4 times 0, but we know 4 times 0 is just 0, so we can leave it as is. Now if we want to write this in slope-intercept form, we want to isolate the variable, and we can do so by subtracting 4 from both sides of the equal sign. So now we've got y is equal to 4x minus 4. One common mistake that happens is students will try to combine the 4x and the 4 and just say y is equal to 0. You don't want to do that because you can't combine those terms because they're not like terms. Now this example is going to be slightly different, and I'm probably going to do this example and one more. So the instructions are the same. Write an equation of a line in slope-intercept form with the following information. This right here is a key difference, the undefined slope. Now based on the conversations that we've had in previous classes, we have a very special type of line when we're dealing with undefined slope, and that is a vertical line. Now in previous discussions, we've also mentioned that when we have a vertical line, x is equal to some number. And then the y variable is essentially not involved. So in this case, we know that x is equal to some number, and how we identify that number is we look at the x-coordinate on the given point. So in this particular given point, the x-coordinate is 0, so the equation for this line is x is equal to 0. If you don't believe me, jump over to Desmos.com, type in x is equal to 0, and then plot this point 0, negative 5, and you're going to see that it does in fact fall on that particular line. Okay, now for my last problem, I'm going to put our point slope form up here. So y minus y1 is equal to m times x minus x1. As you're doing this work, I hope it's getting a little bit clearer of sort of the steps that we take. First thing we want to do is we want to define our slope. And the key thing that I've done with all of these examples, I've given you your slope. There will be some situations where they give you two coordinate pairs and you first need to calculate the slope, and you'd use this formula right here. M is equal to y1, we say y2 minus y1 all over x2 minus x1. And you'll notice that these two forms are actually very similar. Now before we can substitute x1, we need to define it. In this case, it's going to be negative 2. y1 is negative 5. And since these are negative values, we're going to change the operation to addition, because y minus a negative 5 ends up being y plus 5. We're going to have a slope of negative 5, and then it's going to be x plus 2, because x minus a negative 2 ends up becoming x plus 2. So first step, as we've been doing, is we're going to distribute the slope to each of those terms in that particular binomial. So y plus 5 is equal to negative 5x minus 10. As we know, negative 5 times positive 2 is a negative. And then the last step is we identify that this is addition. So we want to perform the inverse operation, which would be subtraction. So we're going to subtract 5 from both sides. 5 minus 5 is 0. So we're left with y is equal to negative 5x minus 15. Now if I were to ask you what the slope is, you already know that. Slope is equal to negative 5. And if they ask you what the y-intercept is, we know that the constant value in the equation that's written in slope-intercept form is your y-intercept. So this particular equation has a slope of negative 5 and a y-intercept of negative 15. I have a bunch more examples here, but I'm cautiously optimistic that these few examples should help you really understand the process. One thing that I would encourage you to take from this conversation are these steps right here. You can use them as they are. You can modify them as you see fit. Just be creative, think critically about this stuff, and really get to know and understand why we're applying the point slope form and slope intercept form and the different reasons why we would be engaging this tool. Anyway, hopefully this is helpful. If you need anything, don't hesitate to reach out and let me know. Happy to help where I can.